Hi everyone, my name is Poe Kyar Phyu, and for my project I built Memoji, a smart command line study assistant. The main objective of my project was to solve a problem we all have. We forget things. This is a well-known concept called the forgetting curve, and the best proven method to fight this is a spaced repetition system, or SRS. So the objective of this project was to build a complete application that does all of the work for you. It quizzes you on your flashcard desk, and most importantly, it implements the SRS scheduling system to tell you exactly when you need to study each test. I also wanted it to visualize study habits with a heat map. Before the demo, it is important to understand the program structure. Memoji isn't just one script, it's a three-file system. First, you have your CSV desk. This is your content. Second, the deck tracker JSON file. This is the brain. It's a read-write file that tracks your progress and schedule for each deck. And third, the study log CSV file. This is the history. It's an append-only file that just logs every session for the heat map. These three files work together to make Memoji run successfully. Now I'll do a live demonstration. Now, I'll evaluate the project based on the rubric. First, completeness. The project is a complete prototype. It's over 300 lines long and uses 12 separate functions. It uses 5 standard Python libraries like CSV for files, datetime for all the scheduling logic, and JSON for the tracker. And it heavily uses all core programming concepts like dictionaries for the tracker and loops for the main menu and quiz. Next, difficulty. This project was deceptively difficult. The challenge wasn't in one function but in 4 main areas. First is the SRS scheduling logic. This isn't a simple save, it's a dynamic process that has to read the current state, calculate the next interval, handle master decks, and write the new state back. Second is the state management. It has to coordinate between 3 different files with 3 different I/O operations for a single action. Third is the console data visualization. The heat map was a graphics problem in a text-only terminal. All of the padding and alignments had to be manually calculated to draw a grid, and some bugs like final new line error had to be fixed. And finally, defensive programming. I had to anticipate all the ways a user could break the app, like by typing alphabets instead of numbers, and handle it by outputting helpful error messages or in wrapping the blocks using try-except loops. Finally, code quality. The code is highly organized. It is separated into a configuration block for global constants, a functions section, and a main block. But most importantly, the code is modular. Every function has one clear job. Additionally, they are named descriptively and their role in the program is explained clearly through the use of docstrings. Comments are also used in the program to make notes, clarifications, and improve overall readability. Lastly, as required, I'm declaring my use of AI. I use AI as an instructional partner, not just as a copy-paste tool. It taught me how to use libraries like datetime by providing me examples of the syntax and crash courses. It helped me brainstorm the logic for the space repetition and heat map system, and most importantly, it helped me find bugs and resolve them. It was essential for finding subtle bugs I couldn't see, like the date format mismatches in the CSV file when I was manually editing data and testing the program, and it also generated the mock data I used to test the heat map and the program's functionalities.